Hi guys, the previous class already we had a discussion on ISO OSI model. In that we already discussed with the 7 layers, out of which we are going to see today physical layer of WSN. What is it physical layer talks about? The physical layer is generally concerned with modulation, demodulation of digital data, and this task is carried out by the device called transceiver. So in general, in sensor network, the challenge is to find the modulation scheme and the transceiver architecture. And whatever the choice of finding modulation scheme and transceiver, it should be simple, low cost, and it should provide with a robust to provide a desired service. So the main concerns about transmission of data and the reception of data, and both are done it using transceiver. So the main function of this physical layers are, the first one is about the frequency selection, that is carrier frequency selection and generation, and the second one is about encryption and decryption, modulation and demodulation, and transmission and reception of data. Along with that, the wave propagation effects as well as noise. So comes to in wireless channel, generally the waves are propagated in electromagnetic waves in free space between the transmitter and the receiver. So the wireless channel we therefore call unguided medium. That means the signal propagation is not restricted to well-defined location, as in the case of wire transmission with proper shielding. So the first one is about the frequency allocation. So generally in WSN model, there is a band called ISM. What is it ISM band? ISM, which is nothing but industrial, scientific and medical. So out of this ISM band only, they can choose which band they are going. So this is an license free bands from the required organization. So using this ISM bands, many other standards like 802.11b and the Bluetooth are also using the same band. So this band, they can have interference less. The important parameters which are to be considered while designing physical layer is few characteristics over there. Before that, we should know what is frequency allocation. Frequency allocation in the sense, it is nothing but generally in practical wireless RF based system. That is, RF means radio frequency. So the frequency, carrier frequency has to be chosen and very correct. And we all know the electromagnetic spectrum radio frequencies like very low frequency, high frequency, low frequency. Then we have super high frequency, extremely high frequency, medium frequency, and they are all depends from the range of 3 kHz to 300 GHz. So in that, from 3 kHz to 300 GHz, they are just splitting the frequency bands. So communication purpose, always there is a finite portion of electromagnetic spectrum which is called frequency band. So out of this frequency band, they are just fixing the range of usual radio frequencies. Either they can go for low frequency or very low frequency, medium frequency, high frequency or very low. So low in the sense it is like 100 km with the 3 kHz. Or if you are going an extremely high, then it is about 300 GHz with 1 mm. So depends on the range of distance, the frequency range has been fixed. So while you are talking about the example for ISM band, IEEE 802.11 and Bluetooth as well as 802.15.14, the general ISM band, that is industrial, scientific, medical band, is 2.4 GHz. So this is the band they have used. So this particular frequency RF based system working, the frequency is below 6 GHz only. The range of the radio frequency is subject to regulation to avoid the unwanted interference between different users and systems. So if they are using a particular ISM band, then they can able to avoid the interferences which will be causing. And moreover, the physical layer design consideration, the first one is about it should have low power consumption, low transmission and reception range, interference from other system, it should be less, low complexity and low duty cycle, which is most of the time sensor nodes are switched off, and low data rate most of the time and high data rate only for a short period of time. So an important parameter while you are concentrating on this particular frequency selection, the antenna efficiency. So what does it mean, antenna efficiency, which is nothing but the ratio of radiated power to the total input power to the antenna. So from which we can able to calculate the antenna efficiency. So whatever the remaining power, it is in the form of the heat. And the small form factor allow only a small antenna. It's like a radio wave is 2.4 GHz, means the wavelength is 12.5 centimeter. So based on the radio waves, the length is also fixed. This is how your frequency allocation is defined. And moreover, the most challenging aspect in the physical layer design is low pass transceiver and the modulation scheme. So generally the transceiver used in sensor network is only about 10% efficiency. Just to radiating the power of 1 milliwatt, it will consume at least 10 milliwatt of power. The power consumed for reception is somewhat similar to power consumed for transmission, and sometimes it may be more or less. It depends on the design of how the transceiver used in the sensor network module. So whatever the transmission or the reception, it's all the power consumption is related to the design of transceiver concept. So we have some models, that is the examples of sensor nodes: Mica node, Wing node, Medusa 2 and Wings NG. The Mica modes, there are 21 milliwatt they are consuming the transmit mode, and 15 milliwatt is consuming in the receiving mode. So the transmission and the reception of the data are most power consuming activity in the sensor. And WIN, there are so many instructions are executing, depends on the transmitting bit. They have given 1500 to 2700. And moreover, whatever the transmitting bit, it's all depends on the consuming nature of the power. Then for Medusa, and the ratio is ranging 220:1 to 2900:1. The summary of the total consumption, the computation, it is all depends on the communication. So general, the computation is very cheaper than the communication. So whatever the power consumption is depends on the transmission modes of operation. In transceiver, there is a mode called idle, then sleep, transmit and receive. In idle, the power consumed by the transceiver will not significantly less than the power consumed by the transceiver in receive or transmit. So they are preferring only the transceiver in the sleep mode, rather idle when not it is required. But when it is put it on the sleep mode, there should be some care must be taken. That is like the power consumed during startup and time taken to start up the transceiver, and it does not overcome the advantage of putting the transceiver in the sleeping mode. And the commonly used transceiver is CC2420. That is the transceiver type they are using generally. So the choice of modulation scheme. So general, the choice of the modulation scheme, it depends on some of the parameter. It's like the binary data, symbol rate and data rate. What is a binary rate? So binary rate, which is nothing but if the common usage of symbol alphabet is 0 to 1. The same thing we can call bipolar, that is -1 to 1. So when referring to speed of data transmission and the modulation, there are some parameters we have to look into. The first one is called the symbol rate. So symbol rate, which is nothing but inverse of symbol duration. So symbol duration means for binary modulation, it is called bit rate. So data rate means it's a rate in bit per second the modulation can accept for transmission. So the rate by which the user can transmit the binary data. So for binary modulation, the bit rate and the data rate are same. Often the term bit rate is used to denote the data rate. So whatever the term we are used to refer, it all depends on the modulation and the demodulation. And there is one more thing called bit error rate, that is BER. So bit error rate is very important while the design of modulation and the demodulation concept. So the data rate is another factor to consider, tells about what amount of data can transmit or receive. And for saving the energy, it depends on how much amount of data is transferred. Then symbol rate is another factor, that is like depends on the power consumption. Then bit error rate, that is BER, it depends on how much the error is possible in transmitter and the receiver. And there is an modified, that is modulated signal, generally depends on S of t is A of t into cos of omega t plus phi of t. That means modulation signal is always depends on the amplitude, that is time dependent amplitude, that is A, then frequency omega, then phase shift phi. So generally in this band pass modulation they are using. For band pass modulation they are using another 4 combinations of techniques, that is called amplitude shift keying, that is ASK, then phase shift keying PSK, then frequency shift keying FSK. So these are also used for the common form of modulation technique. The next one is about the wave propagation effects and noise. So for wave propagation effects, it's nothing but reflection, diffraction, then scattering. This is what wave propagation wave talks about. So reflection, the sense it is like when the medium is propagating a boundary to another medium, there will be a reflection. So the amount of reflected or the transmitted, that is depends on the material or the frequency. Diffraction means the waveform hitting a sharp edge. This can be propagated into a shadowed region. Then scattering, it is like a rough surface. It can be reflected multiple times and diffused into many directions. So these are some of the wave propagation effects. So due to this, there will be some noise also happening. That is also another factor when you are considering this physical layer. Then another one is about noise and interference. Then we have a bit errors. So the bit error is also depends on signal to noise ratio. Then how they are defining the channel models. The channel models are defined like signal model, digital model, then WSN specific channel model. So this is how they are splitting. The another one is called the spectrum communication. How the spectrum, it depends on the packet transmission, synchronization, and the synchronization when you are talking, that is like carrier synchronization, frame synchronization and bit synchronization. This is how they are categorizing about the physical layer design concept. So I think you would have understand how the physical layer design concept in WSN model. Thank you.